Okay, so welcome to the first community call for Dapper for 2020. Fantastic to have you all back. Hope everyone had a great holiday period. This is our agenda for today. We're just going to, as always, dive in to do a few demos of some of the things that have been happening in the Dapper space. Yaron's going to look at profiling inside Dapper. We've got Ridwan from the Ignition group who's going to give us a physics template demo inside Visual Studio. And then we're going to show you what we've been doing with some of the Actor Java SDK from Artur. And then I'll give you a little update on where we are with the milestone plan for 4.0. We'll talk about dates and some of the major features that are going inside that. And then, as always, we open it up for questions. And any question is open, whether it's, what is Dapper, all the way through to why is the API structured like this? And hopefully we'll dive into some deep questions that you may have. So I'm going to stop sharing here. I'm going to hand it over to Yaron, and we're going to kick it off.
Hi everyone, my name is Yaron, and I'm a maintainer on Dapper, and we'll be talking about profiling Dapper inside Kubernetes. So I'll just share my screen. And looks like I'm going to have to rejoin the meeting. Something's wrong with Zoom, so I'll be right back. Okay, now hopefully I'll be able to share. All right, can everyone see on the screen?
Yes.
Yeah, great. Okay, so I'll be showing you how to profile Dapper inside of Kubernetes. And what I have here, which I've prepared, is a JavaScript application. And this is a pretty simple app. What we have here is basically just something that's saving the first act of Star Wars into Dapper. So we're iterating 1,000 times, calling Dapper over localhost. And we have a state with the key of script and the script text, which basically just saves it. So
hey, Yaron, can you make your screen? Yaron, can you make your screen a little bigger?
Sure. Is that okay? Okay, so we have the script text here, and like I said, we're saving a key value to Dapper. Pretty simple thing. So if I run it with the Dapper CLI, we can see that we successfully persisted the state. And if I go here and I curl it locally, I can see the script. So I have a Docker image of that already pushed into my registry, and I'm just going to deploy it to Kubernetes. And this is a pretty regular Kubernetes deployment manifest. We can see it has an ID for Dapper. These annotations are to inject the Dapper sidecar, nothing special here. But what I did add here that maybe not many of you have seen before is this annotation for Dapr IO profiling true. And this is just my container of that JavaScript application. So we're going to save a little bit of data, and then we're going to pretend that we're a developer that thinks that something's wrong with the app because it's using too much memory, and we're going to profile the hip. So we're using something that's called pprof to do profiling and visualization. It's an awesome tool, and I won't have time to teach you about pprof today, but I will show you how Dapper basically sets you up to start a profiling session. So I have this thing here, and I can just quit, and I will apply this to Kubernetes. And if I look at the pods, we can see that it's already running. If I take that pod ID and I take a look at the logs, we can see that it's actually saving state. It's saving state to Redis, which is running inside my cluster. We have the component for that here, state store. And now I want to start a profiling session to see which objects in my memory space are being used the most, or do CPU profiling. So when you enable Dapr for profiling, what it did under the covers was start an HTTP server using the default port of 7777. You can also give it a profiling dashport here to set up the profiling port. By default, it lists on 7777. And once I start the profiling session, I can basically execute commands using pprof. So let's do that. What I'm going to do now is just create a port forward, and I'm just going to zoom in here a bit, to basically establish connectivity between my local machine and the Kubernetes pod, which is running. So I'm just going to do port forwarding for 7777. Great. And what I can start doing now is use the Go tool for pprof, and basically start a profiling session for it. So what we're doing is we're telling pprof to talk to localhost, which is my tunneling to the Kubernetes pod, using port 7777, and start the debug session, and specifically for the HIP. Now, this has multiple options, and really I encourage all of you to go to the pprof page, where you can find more information about the different things and different profiling options that you have with pprof. So I'll just be taking a look at the HIP to just show you how it's done. And so I basically do this, and we can see that it saved a profile for the allocated space in use objects locally on my machine. And now I have this interactive terminal where I can do things like top, and start taking a look at some of the things here. So, this is like a call stack. You can actually see all the calls and some of the information, the data that's going through all of them. And this is the top 10 out of 78. So let's create a visualization of that. You can basically take this thing and continue profiling it and do everything using the interactive shell, but you can also create a PDF out of it. So this is number 10. Yeah, I'm gonna. Okay.
I think you typed 19.
Sorry?
You typed 19, not 10.
Oh, right. Thank you for that. Okay, great. So we generated the report, and it saved it in profile 001 PDF, and now we can just open that thing, and we will see a visualization of everything that's going on. And we can actually see the first place where the fast HTTP append body gets the body. So we can basically see that fast HTTP is getting the response from the body and the amount of data that it's getting. And then we can actually start branching off and see the actual Dapr calls that it's making. So we can see that we have the fast HTTP routing. After treating the body, it's going into the posts on post state method inside the API. Then we can see that it's being handed to the ready state store, and all the way down to ready set value. And then you get marshalling and all that information. So this is pretty useful to start debugging whatever you want, right? So this is just a heap allocation. You can use pprof to profile memory and CPU and allocated objects and object that sits in the value and a lot of other things. So you don't actually need to do anything other than set this annotation for profiling, and then just port forward or set up some other way to reach the pod over 7777 and just start a profiling session. So any questions about that? Oh, and one other important thing, everything I showed you is inside our docs, all that and more. Check out best practices. There's debugging and troubleshooting here. So if you go here, everything that I've just showed you and more is going to be on here, including information on how to debug and troubleshoot Dapr, logs, how to set up tracing and diagnostics, profiling. So some of the stuff I showed here can be seen here. And it also gives you a couple of pretty common profiling methods. And I think there's some things inside the chat window. Okay, thank you. Thanks everyone for the feedback. And again, this is really easy. Go tool pprof is a very easy object to use to do profiling, and really Dapper is all set up for these, and it's not even heavyweight. I mean, you can pretty much debug this thing in production. Yeah, flame graph would be very cool also. So there is actually for pprof, I think there's a GraphViz implementation or something which will show you a flame graph, Howard. So yeah, that is actually supported. Yeah, exactly. Flame graphs are built into pprof.
Okay, that's fantastic. Thanks, Yaron. That's really good.
No problem.
All right. Let's move on then. Let's move on to our second agenda item. We're going to introduce Ridwan and let him take it from here. Ridwan.
Yes, Mark. Thank you for the opportunity to showcase our template on the Dapr community call. My name is Ridwan. I'm from Ignition Group in South Africa. I'm just going to share my screen now. Can we see the screen?
Yes.
Okay. So what I have here is a microservice template to be used with Dapper and Kubernetes. So it's a very simple template that we've started off at the company, which helps us save time in creating microservices in projects. So can be found here at the GitHub URL, which I will forward to Mark to share. And we have also put it onto the marketplace. So the Microsoft Marketplace, you could also download it from here, and it's available in Visual Studio 2019 through the extensions. So let me just go through a few of this. So we've just created a basic README file to give you guys some information about the template and how to go about using it. And I will do a demo in a few minutes on how to use this template. Let me just share another screen. Okay, so here I have Visual Studio 2019, and I've installed the template through the extensions. So this can be found online. So if you look in the marketplace, if you type Dapper, it should come up. So you're looking for Dapper Microservice Template, and I have that installed already. So what I'm going to do is try and create a new project with this. So if I go File, New Project, and if I choose the Dapper Microservice Template, follow the prompts, click Create. This is a custom prompt. Basically, what we've done here is you can specify your microservice application name that would be used by Dapper, as well as the HTTP port that will be used as well. And these will be replaced in the template. I will show you how it gets replaced. So let me just go ahead and create an application. So this is demo 1, 2001. Click Create. And what you have here is the template being created for you. And it has all the basics for a .NET Core app. It's using .NET Core 3.0. It also utilizes Nancy for easy, lightweight HTTP routing. And it contains a few files, a Docker file for deploying into Docker. So this file here, so if you go through this, you'll find that this is going to do your .NET build and your restore and your publish. So when you're building a Docker image, it'll be using this file. In your deploy folder, we have a microservice a deployment file, a YAML file. And this will, yes.
Ridwan, your screen's a little bit cut off on the left at the moment. If you could just scroll to the right.
Oh, yes, yeah. Okay. How's that?
That's better, yes. Perfect.
Okay. Apologies about that. So what you see here is when we had that custom prompt and we typed in there, it has automatically replaced the template with the provided. And that is as well extensible to other settings that we might want. So that's one of the features that we've added in there, which is the custom prompt. We also have a Azure Pipelines file. So this is for Azure DevOps to create a build and deploy pipeline to deploy your microservice into Azure Kubernetes out of the box. So you could, there's some variables here that you fill in, which will specify your registry service connection on Azure. And you can see here as well, it's got the part for the Docker file. It has two stages. It has a build and a deploy stage. And you would find in here as well that the template has replaced most of the information that you would need. So in here, there's just basic. So if you look at the program CS, we've also included some Azure app config, although not necessarily required. You can use it or you could remove it. And in the startup, you'll find it's also replaced your port number that you provided. With Nancy as well, there's a bootstrapper file. So if you look into this file, this is just for the configuration and dependency. If you need any dependency injection, this would go through into this file. Okay, so that's the basic template. And what I'm going to show you guys now is I've created a project or an app using this template. So I'm just going to swap to that one. So I've called it demo service. And I've deployed this into a Minikube cluster, which is sitting on this PC. So if I bring this up, so these are the commands here that I've used to build the Docker image. So you would use a Docker, we use Docker build to create the image. We used Docker tag to tag the image into our repository. We pushed it up. And we've applied the demo service deploy file, which is this file here, and to a container into the Minikube cluster. Okay, so I'm just going to show as well that we have it running here. So I'm just going to grab this command. So this is what I have in my cluster at the moment. So we have Dapper running, we have Dapper dashboard, and we have the demo service. Okay, so I'm going to run enough commands just to show you guys that so to bring up the Dapper dashboard. So here you would find that the app is successfully running. It's running on port 3009, and it's basically in the Minikube cluster. Here again, now what I'll try and do is actually try and access this microservice. So to do that, what I've done is if you looked at the pods, so just get this, you will find that I had to create a load balancer type of deployment in order to expose the demo service. And you'll find that the external IP is pending. So in order to expose that, you have to use the command minikube service my service. And let's just wait for that to start up. Okay, so what has happened here now is that we've been assigned an external IP that will point to the service, and you'll find that it's currently looking at the default get call, which is, if you look into the Nancy module, which is hello world. So let's just try and change that to another call. So this one. And as you can see, this is running successfully in the cluster. Okay, so any questions on this?
I have a question. Can you hear me?
Yes.
Yes.
Sometimes I see people using two different endpoints, one for the Dapper API callback and another one for the main service API. So those sometimes get decoupled. Is there a plan in your template for you to offer two endpoints instead of just one?
Yes, we have done that, but although I don't think from what we have seen, the port number for the app actually can be the default port, and it should still run. But how we've built this is each microservice will have a different port number.
I know, but in a simple, what I'd say is the API that Dapper call back into the app is usually different from the one that the app exposes to the other
Yes.
microservices. So there are two different ports usually. Do you plan to support this model as well?
That's a good question. I'm not sure how to answer that one. Does anyone maybe know how to do that?
In my demo, I will show an example where we're doing something similar for Java. I will show an example where there are two services running, one for Dapper and one for the main API. But I just want to let you know that that might be something that people might want to use in the template.
Okay. Okay, that's cool.
Yeah, thank you. That's
Yeah,
great.
thank you. Yeah, it's fantastic. I love the template.
Thanks a lot.
Do you have any plans at all? Any feedback so far on things that you may add in the next?
Yes, we have had some feedback where we might plan to remove Nancy and just use the default .NET Core routing.
Oh, but I love Nancy.
Yeah, you mean
yes,
you mean the .NET Kestrel server, yes?
Yes.
The webhooks,
server.
yeah. Yeah, you probably
Yes,
that might be the cheap choice at the beginning. Maybe you can have those.
Kestrel with endpoints or ASP.NET Core with MVC, I think.
Yes. Yeah, so we have had some pull requests on that. We're still debating on whether to change it or to continue with Nancy.
Right.
Okay.
And Russell also said we'll also build a template for actor generation. Yes, that would be a great one for actor side of things as well, because this was effectively building HTTP endpoints as the actor side of things that we have, which is actually matured quite a lot on the .NET side. It'd be great to see one there.
Yes.
Perfect. This is fantastic, Ridwan. Thank you. Very, very good indeed.
And one thing that you mentioned, Kestrel with endpoints or MVC with what did you use the term? However, there is also the middle version, the new one, and the recommended one. It's like it was Routes, the Project Houdini version of ASP.NET Core, where they allow to work without MVC, and use all the goodies of ASP.NET Core straight in the middleware level. So this is the, to me, this is the preferred solution. And I believe that also this is preferred for ASP.NET Core team.
All right, yeah, when we're in
Yes,
touch with the ASP.NET Core team, we can surely talk to them and get a recommendation from them, but we will bring it up. Thank you, Mauricio.
Okay, thanks, Redwan, that's fantastic. So that leads us on now to Artur, and we will now just transition over that to talk about what we've been doing with the Java SDK, and particularly the sort of actor implementation inside that. So Artur, take it away. All right, I think Artur had to drop out and come back in again and reset his Zoom.
Yeah, that sometimes happens.
Yes. All right, okay, here he comes.
I have to reconnect just like Yaron.
Yeah, okay.
Okay, let me share my screen now. Can you see my screen?
Yes.
Good, okay. So these are work in progress on the Java SDK, and I'm gonna show how you can implement actors in Java, okay, for Dapr. So I have a demo application here, and as you can see, there's a demo actor implementation. So in this particular example, we register a timer. We also register a reminder, basically by inheriting from the abstract actor. And we can implement a method, let's say to say something, or clock, just to show the clock. And we also implement the receive reminder that we're gonna get the reminder from. The receiving reminder is an implementation of the remindable interface. So if your actor wants to implement reminders, you have to access from this interface. And demo actor is the one that your application will implement. In this case, we have register reminder, say, and clock. So these are the example of the implementation. On the client side, we have a proxy that by getting a new instance of actor proxy builder, you can basically say, well, for this actor type and this actor ID, give me an actor. And the actor proxy automatically knows how to talk to Dapper and give you an interface for you to invoke methods in the actor. In this example, we spin off a number of actors, each one saying a message, basically invoking the say method in the remote actor, okay? So, and this happens a few times, and then it prints out to the console. On the server side, we have implementation uses Spring Boot. So in this particular case, we get a port for the command line. We write to the actor. So when Dapper spin off on the server side, it knows which actors are active. And we start the Dapper API callback. In this example, the Spring Boot application also has an API. So in this case, we also run the application endpoint. So in this example, there are two endpoints running, one for the Dapper callback and another one for the main API. And the hello controller is just an example of how the Spring Boot application would do. In the Java SDK, let me open that up. Give me a second. There you go. In the Spring Boot integration, we have the application itself that knows the port and knows how to start itself. And we have all the callbacks implemented. For this particular version is only actors. We're going to add more before we release. So in this example, we just have the actors entities here, the activation, deactivation actor, invoke actor. So all these methods are handled in a different port than the main application, okay? And that's by design. So let me run this so we can see it working. So let me expand my terminal here. It's hard to see the command line. Let me just copy and paste from the IDE. So on the server side, you do, after installing, of course, you do Dapr run, the app ID, the app port. This app port is the port for Dapr. It's not the port for the API, the main API. The port Dapr will listen to, and then there's a Maven command to run the example, okay? And again, you pass the parameter to say, listen to port 3000. So I'm gonna copy this command. It doesn't become readable because of the terminal, because it messes up with the display. So let's run this. So as you can see, Spring Boot you have 2 messages from Spring Boot because we're listening on 2 different ports, okay? And as you can see, Dapr found the application on port 3000. And here with these messages, you can see that it knows it has actors registered, okay? Now if I open my browser, not my fitness membership, localhost 3000, you're gonna see Dapr. If you do 8080, you're gonna see the Spring Boot application. These are 2 different endpoints. And if you do 3000, for example, Dapr config, you're gonna see the same configuration that you saw from the implementation here, okay? So now let's run the client side. So the client side has a similar command. You basically, the Dapr run and the Maven command, very similar, demo actor client. You don't have a port because the client doesn't listen to any port. You just need to pass in the parameter for the Dapr port, and by an environment variable, the application knows which port to talk to Dapr to. So you don't need to pass in any argument, just the environment variable set. And now I'm gonna paste a command on another terminal here. And it's gonna simulate a client using actor. So as you see, you got a reply for all the messages, and the different actor instances. There's a different ID for each. And if you look at the actor, you got the messages, server, same method for actor, this, sad message, that. And we also have a reminder being triggered. And we also have a timer being triggered. So if I leave the terminal running, you're gonna see the ping and the remind over and over again. Okay, that's all on my end. Let me stop sharing. Any questions? Hello?
Yeah, we can still hear you. So this is all part of our Java SDK. So we'll be seeing, we'll be seeing this kind of. This is currently. Where are you with this currently checked in at the moment?
It is currently checked. This particular version, it's in a pull request. Everything's being merged to a branch called Java SDK whip for work in progress. So people can check it out if they want to see the progress on that.
Does that include the samples that you have there as well?
Yeah, the samples are there as well. Everything's together. Java SDK whip. That's the branch name in the Java SDK repo.
And if anyone wants to help us build out more actor SDKs for other languages, that'd be great. We love our contributors.
Yes. So as you can see, what we did is when we first released Dapper, we had an actor SDK for .NET and C#. Now the most popular request after has been the Java one. That's what Artur's been working on. So, I'd love to give you any feedback on this. Download from that branch and kind of play with it. And then, if there are other languages like particularly Python or JavaScript, we'd love to have work on some of those as well.
Do we have any Java developers in the call? Yeah, maybe not today.
Okay, thank you. That's fantastic, Artur. Well, we'll post a few of the notes on that, and let's move on here a little bit. Let me just share my screen here. Just let me give you a little update now on where we are with our milestone. So we're in milestone planning at the moment for our 4.0 release. You've just seen some of the Java work we've been doing on the Java SDK. On the last community call, the one that we had back in December, Yaron went through on the security MTLS work, which was security between Dapper instances, and that's progressing well as well. And we'll probably have an update of that in our next community call, along with as well how we're doing implementation of multiple state stores. So that means now that you can have today, right now, inside your Dapper deployment, you can only have a single state store shared across all your Dapper instances. We're making sure you can have different state store instances for each one of the Dapper applications that gets deployed. So we're working through this as well. And then our next community call, we'll dive into this and go through this proposal. But feel free to look into this proposal here as well, which is this one here that we're updating. And we're doing comments on this and doing design reviews on this. So this is where we are with the state of this. And effectively with our 4.0 timeline, we've got a TBD here right at the moment, but it's looking very likely that we will release the 4.0 release of Dapper for the runtime and the Java SDK 2.0 release sometime in February. We hope it'll be certainly in the 2 weeks in February. So about a month from now, maybe 5 weeks from now. That's the sort of timeline for this. All these three things are kind of fairly big, complex pieces of work. We'd make sure you get lots of testing done inside them all. We're doing this all sort of in the open, so you can see everything's happening inside there. But the timeline for that looks like around, say, the beginning of February, beginning to middle of February. So think about between, probably the first and second week of February. We'll have actual detailed dates for this on our next community call. We'll actually lock the date then. Meanwhile, of course, there's lots of other smaller fixes going in, and generally to the runtime and doc updates and things like that. So keep watching out for those. All right, perfect. So at this point, I'm going to stop sharing. We've got about 20 minutes left for any questions that you want to post. Feel free to post them in the window, in the chat room, or just unmute your microphone and just start asking some of the questions. And we have one here already from Marcin. When can we expect go live for Dapper? At this point in time, we don't have any date set for a go live for Dapper. We know we're going to attempt to do it. We will have a go live license available this year, but at this point in time, we're actually working both on a lot of internal projects and directly with some customers as well, who are actually building quite complex solutions on Dapper. So we're going down the philosophy of we build it, we see real world solutions, we get those into production, we give those customers go live licenses first, we help support them and run them, including a couple of big internal projects we're working on. And once we have that and we know that it's all running and stable, then we declare a go live. I guess it will probably be, we don't have a date yet. We'll tell you later on this year. So 2, could you explain how security services is going to authenticate sidecars?
Yeah, I can take that.
Okay.
So we talked about the authentication, I think, in a previous community call, and it's gonna take a whole while to explain that now, but there is an issue about it in the issues section, the details of the architecture. Yes, and about 3, why not use SDS? So actually we are using something very similar to SDS. I can't speak for AKS when it will support it, but for the way we're going to do mutual TLS is something which is very similar to standardized SDS. What will be the preferred state store for Dapper in Azure during GA? We don't know.
We don't know, but I mean, Cosmos is one of those. I guess we'll point towards Azure Storage. I mean, any of the G8, we're going to support any of the G8 state stores.
And 5, I think that's for you, Mark.
To provide a PaaS version of Dapper on Azure App Service. It'd be a really cool addition if one could provide it. and can provide a Dapper manifest along with a container image when deploying to Azure Web App. So this is all about how is Dapper going to get put into Azure services. Yes. So we've been talking through sort of concrete plans about what that looks like. We don't have anything that we can share just yet publicly, but the idea is at least to get Dapper into the hosted services. I mean, you have things like App Service, you have AKS, and inside those services, we want to have Dapper as a first-class experience inside Azure. But I think you need to give us kind of a couple more months yet until we formalize some of the plans about what it looks like and see how that actually integrates. So, hang around, maybe have an update in a few months' time, but certainly that is the goal. All right, we have another
couple of questions about Service Fabric.
There's a CNAP question here first. We Engine are working with Ralph Scolacci and the Porter team to create the CNAP Cloud Native Application Bundle quick start samples. Just for Christmas, I created a bundle that included Dapper. Fantastic. Hopefully next quarter, Porter will support dependencies and we'll have Dapper as part of that. Okay, when are you working on getting this working with Service Fabric? We're still, that's in a similar answer to the question I gave with all our services. So Service Fabric, App Service, Kubernetes, all those teams, which are separate teams from the Dapper team, are actually working on how they integrate Dapper into their solutions. And they're all working differently and independently. The one that we have, I'll repost a sample actually. We started a sample of how you could deploy Dapper with Service Fabric today. We then had to do a piece of work where we actually exposed the invocation endpoints as an API that we did back in the 3.0 release. So maybe an update again that in the next few months, but I don't have an update on that at the moment. But again, it's the same direction. We will make Dapper work first class with Service Fabric. I just don't have a timeline of when that will happen, same as I don't have a timeline with AKS or App Service at the moment. But in the next few months, those timelines will emerge from those teams as they set their schedules. But it is on the radar, yes. Is there any support for service health checks? You might have to explain that a little bit more. When you say health checks, you mean probes onto endpoints, like you have health checks from Kubernetes health checks? Be good if you, as AZ, it'd be good if you open up your microphone and just talk about what exactly you're looking for. Hey guys, along these lines, can you please tell me when we'll support Azure Service Fabric remoting service model as well? I don't think we have those on our plans at any moment at this point in time to do the remoting service. That's very specific to Azure Service Fabric. At this point in time, we ported across and moved the active model, but we're not going to be moving the Service Fabric remoting service as well. Marcin says first class support, awesome. for Java, I presume. Have you given some thought of integrating that with durable functions and durable entities?
Oh, we have, haven't
yes.
we?
Do you want to spend some time talking about that, Yaron, or?
Not particularly, do you?
Yeah. Well, yeah, so the answer is yes, we have. We spend a lot of time talking about with the durable functions team and durable entities. And at this point, I'd say that we have ideas in place, but we don't have any concrete things that we can actually share at this point in time. We actually have shown how you can use the functions runtime with Dapper in order to bring features to it all. So if you would take the functions runtime, in fact, one of the samples that we have shows the functions runtime doing pub sub between two deployed functions inside a Kubernetes cluster. But we're still having a lot of discussions with how we integrate Dapper more deeply with Azure Functions itself, but we don't have anything I can share at this point in time. Again, maybe in the next few months. One point of clarification I've not been able to find elsewhere: how do you see the relationship between OHM and CNAP? So OHM, which is the Open Application Model, is a deployment description of how it deploys the application. It doesn't say anything about what the application is. Dapper is all about how you write the code for your application. So those work, Dapper and Ohm work very well together. We've shown examples. In fact, maybe what we'll do on the next community call is we'll do a demo of Ohm and Dapper working together to show how you can deploy applications, Dapper applications with Ohm. And CNAP is a bundling thing. See further back up on this call, Ralph Squalaci, I'll see if I can dig that out and post that, show how they can bundle. It's a bundling technology, a bit like how you do a deployment set of artifacts that can contain Dapper applications and deploy inside them all. Again, CNAP has got nothing to do with how you write your application. It's merely how you deploy your application. The CNAP bundles can also be deployed through Ohm, I believe, but I'm not too exactly up on the details there. But yes, Dapper plays nicely with both Ohm and CNAP. Martin replies, health checks are more in the scope of Ohm. Yes, the health check's more about how you put probes onto your endpoints and say that the endpoint is alive. We haven't built anything specifically like that into Dapper or intend to in any way. It's more of as a infrastructure type choice about how you want to do probes onto health checks on your endpoints.
Yeah, and if you're running Dapper on Kubernetes, you can just use regular primitives for health checks on your Dapper deployment. So you can utilize health checks for Dapper.
Remoting makes sense. More specifically, this came back to the remoting side of things. Yes, we're not building an interface-based remoting model in any way at the moment for Dapper. We don't see a need for that. gRPC is probably the best choice there. I mean, stick to gRPC in terms of describing.
Or actors, because actors do give you an interface-based model.
Or actors, yes. Actors, yes. What should be the project GA timeline to be able to join Dapper previews? You can join us now if you have a project. If you have a project that you think that you are going to use Dapper in, then you can dedicate some time and resources to that, and it's a project that you intend to take into production. We would love to hear from you. Reach out to me, mfussell at mfussell@microsoft.com. We have a number of customers that we're working with at the moment, and if you're willing to open up some development time, we will work with you, and we'd be more than happy to spend that time working with you on a joint project. Beyond that, we will just continue to push out more updates to Dapper as it solidifies. So yes,
to be honest, I was even considering just using Dapr D inside as a side process in the container, because it was like it would save like several days of development. Yes. Of integrating some, I don't know, storage queues or stuff like that. And we need some abstraction, and just running Dapr as a sidecar and telling developers, especially Node.js developers, to expose just HTTP endpoint and handle and return 200 if they are happy with if they handled the message correctly. It saves like tons of development effort in our scenarios, and it also provides the cross-platform, cross-cloud, so it's really great thing for us. And
yeah, that's great to hear. Thank you.
Yeah, and the problem is that Kubernetes is not ready yet, from my perspective.
Kubernetes in general, AKS.
AKS is not ready yet for me. So I was like thinking to bundle Dapr D together with application as a background process in container and provide manifest as part of configure container layer. So it was like a very, let's say, suboptimal solution, but still it would provide a lot of value added. So
yes.
Really looking forward to use Dapper, and it's like perfect abstraction to me.
Good. Yeah, so hey, you're saying you bundled Dapr D just as an executable into an app service deployment, yes?
I wanted to deploy it as a as a background process inside the container as a secondary process.
I see.
But so using some not recommended approach, because the app service doesn't support sidecars, right? So I wanted to embed two processes into single container, what is not the perfect solution. But the problem is that lack of support for Dapr. Despite this is a very simple scenario, is a problem to me to use this kind of approach. So if it's possible to get some support, I have projects that we would love to early adopt Dapr.
Yeah, well, Marcin, let's kind of speak more offline.
Yeah.
Support. I mean, let's just be clear where support is. I mean, support for Dapr will come in sort of two forms. Eventually, Dapr, like .NET, will become, Dapr is an open source project. So in that regard of things, it'll always just be an open source project about how you use Dapr and deploy it yourself. Support will only actually truly come with Dapr integration to Azure services. So when Azure, there you'll get the support. But that is going to take a longer time frame than when Dapr is, and that's actually up to the teams themselves for app service, service fabric, and for AKS of how they integrate it and when, based on all their other priorities. So there's always a role here we have to play about getting some projects off the ground that will not necessarily be fully supported yet, but we the Dapr team are willing to spend time with you to help you.
I was rather thinking about getting like confirmation that some parts can be used at the production, or some parts.
Well, no, there's no. I mean, just to be clear, there's no production support where at this point in time, Dapr, where you phone up and go to Microsoft customer support services and say, "I've got a problem with Dapr." At the moment, it's an open project. We will get there. We will get there with the services, and then, of course, how we'll get there with the open source project is still something that we're working through.
Okay, so this is a bigger issue, right?
Yes, it is. Yes, but in the services, when we get there, that's where it will be supported at least. But that's going to take a little bit of time just yet.
Okay.
Yeah, you won't see it. You won't. It's. Let's see. It's still several months away from that. Yes. So don't expect. There isn't any support on Dapr right now in terms of that. It's still an open source project that we're developing out and pushing these things on, but with engineering support around this. I mean, we have an engineering team that's building this out, and we're continuing to expand an engineering team very, very rapidly.
Awesome,
okay.
thank you.
All right. So service fabric remoting is really quite good, especially the ability to remote on task of type. We make use of a lot of service applications, and we said it was missing. Yes, there was a huge amount of work that was put into the service fabric remoting, but it was very deeply embedded into service fabric. So wonderful use of that technology, but you won't see that coming into Dapr anytime soon. Yaron posted a sample for Azure Functions. Fantastic. And we're nearly at the top of the hour. Good. Any more questions that people want to talk about? Any other questions? Well, this has been a fantastic community call again. I will post this online on the YouTube channel. The next one will be held in 2 weeks' time from now. So that will be on the 21st of January. We'll have more demos then. We'll have an update on where we are with our Java work and with the 4.0 timeline. And I'll also arrange to get a demo between the open application model and Dapr at that time as well. So thank you, everyone, and enjoy the new year.
Thank you very much, you too.
Thanks.